we've seen how to do a one sample t-test by hand, just by thinking that the t statistic, the one number summary of our data, can be calculated by taking our observed mean, seeing how far away it is from the hypothesized mean, and then dividing it by the standard error of that mean. In a way, the t statistic is how weird are my data? How many SEMs is my mean from the hypothesized mean? And if the t statistic is big, it's a sign that that's pretty weird. Maybe you need to reject the null hypothesis. I'm going to show you here how you can run a one sample t-test in Stata. So we have this hypothesis that you can fit 72 ounces of beer inside a Frisbee. T is our one number summary of the data. We saw how this is calculated. The numerator, the denominator is the SEM, and we get this number of 10.49. In Stata, there are two ways to do it. You can point and click your way to almost anything in Stata. A one sample t-test is under this statistics, summaries, tables, and test. And then we call this a classical test of a hypothesis. And this is a t-test. If you want to do this in Stata syntax, it's really easy. T-test, and then you need to put the name of your variable. Say it's called volume, right? How much liquid you put in the Frisbee. And then you need to put in the null value. Where did that null value come from? Well, someone just pulled it out of their ear, right? This is the hypothesized value that I want to put in here. So when I run this line of code, or when I point through this line of code, I'm going to get some Stata output. And this is the output for a one sample t-test. Here's my code. T-test volume equals 72. That's what I run. And here's the output. It will show me my N, the number of Frisbees, my sample size. It will show me my mean. So that's my X bar. Here's N right here. It shows me the standard error of that mean. I just want to recircle that. That's the standard error of the mean, my SEM. It calculates the standard deviation of those 10 Frisbees that I have. And then it also makes this confidence interval saying we are 95% confident that the average Frisbee holds between this and this fluid ounces. Now, we also get the results of the t-test itself, the hypothesis test itself. And you see it right here. Here's the t statistic, 10.4. The same thing we calculated by hand by saying t equals X bar minus the hypothesized value divided by the SEM. You can confirm all that by looking at these numbers right here. I'm not making this up. And in fact, it's actually a good test of your comprehension and interpretation. Cover up one of these numbers with your thumb and see if you can calculate it by hand using the other numbers in the table. Now, that's our t statistic. And if you look at the bottom, here's where Stata prints out the p-value. You see it says ha. That's not actually ha. It's the alternative. It's H sub A, the alternative hypothesis. And it says mean is not equal to 72. Remember, we said that the null hypothesis, which is not the HO, but the null hypothesis is the mean equals 72. The HO and the ha would be the mean is not equal to 72. Now, remember, what's the definition of a p-value? The probability of observing a test statistic of a given magnitude or larger if the null hypothesis is true. Look at this line right here. You see there's PR, that's the probability. You see there's that T, right? Test statistic. You see there's a greater than sign, right? This is the definition of a p-value. And here you see that Stata prints out 0.0000. Now, this is unfortunate because remember, I'm going to draw a curve in the top right corner. Remember that the distribution actually never touches the axis. All events are possible. Rare events happen, rarely, but they happen. So the p-value can never be exactly zero. It can be small. And in fact, this one is so small that theta runs out of room, there might be some more zeros and then a 1 somewhere over here. So how we need to report this is P is less than 0.0001. Now we can think about this means sort of in English. I like this here. If the null hypothesis were true, in other words, if you actually could fit 72 ounces inside a Frisbee, chance alone resulted in the variability that we get, we would get results like this. That's what a p-value is. What's the chance of getting results like this? Less than 0.001% of the time. So again, either we're really unlucky, or maybe that null hypothesis is wrong. Whoever spewing this out or promulgating it as conventional wisdom, maybe it's wrong. Maybe we have evidence to reject that null hypothesis. What we can do with our p-value is compare it to some standard, some sort of standard of evidence. And that's going to be called the alpha level.